All right, we are continuing our look at Alberta's Algebra and Number 3 curricular outcome, specifically dealing with rational exponents. We'll take a look at our curricular outcome and then we will review some information and dig into what rational exponents are. Our outcome: demonstrate an understanding of powers with integral and rational exponents. Let's review. So if the nth root of x is y, then that means y exponent n equals x. So if y squared is x, then y is the square root of x. If n cubed, or if y cubed is x, then the cube root of x is y. So what does that mean with rational exponents? The very definition here, the nth root of x is nth root of x exponent n, so that's x. Right? The square root squared, the cube root cubed, the fourth root to the power 4. Those will cancel each other. We're just left with our original number. Our exponent rules also say if we have an exponent of an exponent, then it's multiplied together. So x to the 1 over n times x to the n becomes x to the n over n, which is x to the 1, that's x. Well, notice here we both have something in brackets to the exponent n equals x, with no real restrictions on what x and n are. That means when they match the forms, whatever's in the bracket has to be equal to each other. So the only way these work is if what's in the bracket matches. So the nth root of x is x to the 1 over n. This is how we interpret exponents with denominators. The denominator is that root of the number. So that's the whole point of this lesson and this topic. The square root of x is x to the 1/2. The cube root of x is x to the 1/3, and so forth. So how does this work in practice? What are some examples? Let's calculate 512 to the 5 over 9. Well, that over 9 bit tells us this is the 9th root. Right, we can break it up. So first 512 to the 5 over 9, we could take our 512, do the prime factorization, that turns into just 2 exponent 9. Now we multiply our exponents together, and the 9's cancel. We get 2 to the 5th. That's 32. Here we want to solve for x. Well, an exponent raised to an exponent, you multiply those exponents together. So if we want to get x to the 1, when we have x to the 4 over 7, we raise the whole thing to the exponent 7 over 4. What we do to one side, we have to do to the other. The left-hand side becomes x to the 28 over 28. That's x to the 1. The right-hand side, it's the 4th root of 81 raised to the 7. The 4th root of 81 is just 3. So x is 3 to the 7, or 2,187. Third example. 3 to the 1/2 times x to the 2/3 is 2 to the 4/3 times x to the 1/2. Let's solve for x in this one. Now, one option is to note all of our denominators are either 2 or 3. So we can take a few approaches here. We could raise everything to the 6, wipe out all of our denominators immediately, and then we're just left with normal fractions here. The other option is to divide both sides by x to the 1/2 and deal with the fractions that way. So if we divide by our coefficients, divide both sides by x to the 1/2, it cancels on the right, shows up under the x to the 2/3 on the left. Divide both sides by x, or 3 to the 1/2, and it shows up under our 2 to the 4/3 on the right. Now our x's become x to the 1 over 6. Now again, we raise everything to the power 6. multiply those through, continuing here to get it all to fit on one screen. We get x to the 6 over 6 is x to the 2, exponent 24 over 3, and 3 to the 6 over 2. We can simplify these further. 2 to the 8 over 3 cubed, and x to the 1. So x is 256 over 27. Had we raised everything to the 6 from the start, we would have had 3 cubed equals x to the 6, x to the 4. 3 cubed times x to the 4 equals 2 to the 8 times x cubed. Our x to the 4th divided by x cubed cancels, and our 2 to the 8th over 3 cubed simplifies as it did here. Here's some examples for you to work on. Calculate 729 to the 5 over 6. Pause now if you need more time. Right, so 729 to the 5 over 6, we break it down as powers of 3 and resimplify. 243. Exercise 2. Solve for x when we have x to the 3/8 equals 8. Pause now, take whatever time you need. Here, we raise everything to the exponent 8 over 3, and that will cancel our exponents on the left. The right-hand side just becomes 2 to the 8, or 256. Exercise 3, we're going to solve for x when it appears twice. Pause now, take whatever time you need. Taking it step by step. We bring our x's to the left, bring our 32 and the other constants to the right. We deal with our fractions. 23 over 12 minus 1/4 is the same as 23 over 12 minus 3 over 12. Or x to the 20 over 12, with 3 to the 5th over 2 to the 5th to simplify. Continuing from where we left off. That 20 over 12 reduces to 5 over 3 when we take out the common factor of 4. Raise everything to the 3/5. And we end up with x is 27 over 8. Right. In summary, the nth root of x is x to the 1 over n. If we have a rational exponent of denominator n, that's the same as taking the nth root of the base. When solving for a variable with a rational exponent n over m, it is often useful to apply the exponent m over n to both sides. That'll turn your exponent on the variable into a 1. If you have any questions, any feedback, leave them in the comments, and I'll try to respond in a timely fashion.